Hello, I'm Steven LANOE. I work for Sopra Steria as a simulation architect, and I'm delighted to be here today to talk about the application HoloGRAM, so Holo and Graphical radar cross-section measure. We develop a radar signature visualization system with HoloLens glasses. For us, augmented reality is a tool to accelerate the analysis of results of experiments and simulations. So I will start with the context. I explain what is a radar cross-section, then the goals, the techno we use, and finally a demo. Firstly, the context of the application. So radar cross-section, RCS, in French, surface equivalent radar. It's a measure of how an object is detectable by radar. A large radar cross-section indicates that an object is more easily detectable by radar, by an enemy radar. Multiple factors influence the radar cross-section. The material of the target of the aircraft, the absolute size of the target, the relative size of the target in relation to the wavelengths, the polarization of the wave, and so the incident angle of the wave. So actually, these measures are realized in anechoic chamber when the aircraft is immobilized. The aircraft is placed in the center of the anechoic chamber, where the walls are covered by stacks of radar-absorbing material. To begin, the radar is in front of the aircraft. It sends the waves. And the direction of the aircraft and the part of those waves are reflected, and we photographed these waves in a file. When the radar is on the left side, the measure is different because from this angle the left wing is more detectable. So the color are it's on the left, the white color, the aircraft is undetectable, but if it is black, it's more detectable. It's called shining points because it's the points the enemy can see in their radar. And it's the same behind. We have different. So when the point of view of the frequency changes, the radar signature changes. In profile, it's stronger. We can see more these aircraft. All these files are post-processed, visualized and analyzed by experts in stealth on off-ice workstation far from experimental sites. This model has many points sensitive to radar waves. The air inlet and the weapons under the wings are particularly detectable. These points in black are called shining points. Now the goals of our application, HoloGRAM. First goal is to visualize the stealth of military aircraft directly on the target, on the aircraft. The application has to recognize the target, place this target in the world space, overlay stealth data, the radar cross-section, on the real target, the aircraft, and mix all the results into one file. HoloGRAM can be used at any point in the production cycle, from design to maintenance. Here, the second goal is to control the maintenance of performance throughout the life of the aircraft. Indeed, today, mechanics and pilots perform visual checks. However, it's necessary to provide a device for checking the stealth at regular intervals in a theater of operation. Now the techno we use for the application. So the application is deployed on HoloLens because we want that the user to have a free hand and see its environment, so the aircraft. So HoloLens has sensors for environment understanding and human understanding, spatial sound, gaze tracking, gesture input, and voice support. We use Unity because it's the easiest way to create mixed reality application. And we use the Mixed Reality Toolkit. It's an open source cross-platform, and it's intended to accelerate the development of application targeting Microsoft HoloLens. This project of Mixed Reality Toolkit is aimed at reducing barriers to entry to create mixed reality application. And we also use Vuforia. It's an augmented reality software development kit, SDK, for mobile devices. We use the feature of model target to track and recognize an object, the aircraft, and from its shape of the real object. We don't have a QR code on the aircraft. So the demo takes place in 2 steps. The first step is detection of the real target. So an aircraft comes back from mission. We want to visualize its tails and compare it with the measurements made previously on the same aircraft. So we have to recognize it from its shape. So in white, it's the first step of the application. When the application finds the real target, it knows where is the aircraft, and so we can see the stealth data and overlay it on it. So here is a demo on a model of 2 meters. We recorded what the user sees through the HoloLens. The aircraft model is real, and we see the stealth on it. So, as you can see, the color represents the different level of stealth. Okay, so in white is undetectable, and in black is detectable, black, purple, and red. So, the user position with HoloLens is the radar position of measures. And when we are on the side of the aircraft, the right wing and the weapon are very detectable. But in front of, it's okay, it's more undetectable. The azimuth, the angle between the user and the aircraft, is calculated in real time between user. So if you turn around the real target, the application overlays stealth data corresponding of the azimuth. So HoloGRAM enables to detect more quickly the defects of the military aircraft. The tool enables to visualize in augmented reality the defects directly on the aircraft, and this tool is very useful because it's not always possible to see the defects with the naked eye. The many flights and the aging of the aircraft cause a deterioration of the stealth, which today will be difficult to measure regularly because it's impossible to immobilize systematically the aircraft or use an anechoic chamber. HoloGRAM will transpose the end user who will view the stealth measurement directly on the real object rather than on a representation on a post computer. away from experimental sites and on static images. Here the user can move around the target to study the results. The final system enables to compare cells with the measurements made previously on the same aircraft, and secondly with the reference radar signature captured in an optimum condition of an anechoic chamber. HoloGRAM enables to visualize the stills measurements through several HoloLens at the same time to facilitate the expert analysis. And HoloGRAM improves the communication of expert analysis and simplifies the presentation of results and the communication. So we are working on the exploitation of 3D data via sensory experience with high added value. Our role as a large integrator is to help our customers to industrialize this technological chain from the production of 3D data to its use by the operator in the field. We approach this responsibility by working on both the business impact and the implementation of a professional platform that rationalizes the cost of development. So don't hesitate to meet us on both E15 to test all our demos and this demo of HoloGRAM, and now the software bricks that we can develop and how to integrate specialized partner solutions. So I hope this has been informative and useful for you, and would like to thank you for your attention.